Every day we do hundreds of things, without asking why. Why does a pen cap have that little hole? You probably have a pen on your desk right now. Go ahead, pick it up. See that tiny hole in the cap? It's not just a random design choice. It's a life-saving piece of engineering. Why are shirt buttons reversed? It's a direct link to a time of aristocrats and servants. These aren't just random trivia facts. They're elegant solutions, hidden in plain sight. They reveal so much about our history. They reveal our psychology. They reveal our biology. So today, we'll peel back 5 everyday mysteries. I promise you will never look at a pen cap the same way again. Let's dive in. Alright, first up, the humble pen cap. We see them, we use them, we lose them. But that little hole at the very top? It's not there to keep the ink from drying out. In fact, it has nothing to do with the pen's function at all. It's there because of a very human and very dangerous habit, chewing on things. Every year, a surprising number of people, mostly kids but adults too, accidentally swallow and choke on pen caps. The object is just the perfect size to get lodged in your windpipe, creating a complete blockage. So, engineers at companies like BIC came up with a brilliantly simple solution. They added a hole. It's not a big hole, but it's just big enough that if the cap gets stuck in your throat, it allows a small but critical amount of air to pass through. This provides a vital lifeline, buying precious minutes for medical help to arrive. This design is so effective that it became an international safety standard, ISO 11540. The standard specifies that caps must be ventilated to prevent asphyxiation. So it's not just a good idea. It's a rule that has been demonstrably proven to save lives. It's a tiny, almost invisible piece of preventative engineering that turns a potential tragedy into a manageable emergency. There's also a secondary, less dramatic reason related to manufacturing. When the plastic cap is molded, having a hole at the end helps equalize the pressure inside and outside the mold. This prevents defects and makes it easier to pop the cap out of the mold cleanly. It's a small detail that makes the production process smoother and more efficient. A happy little coincidence that aligns with the primary safety function. So, the next time you find yourself mindlessly chewing on a pen cap, you can thank some clever engineers for thinking ahead. That tiny hole isn't a flaw or a fluke. It's a deliberate, life-saving feature that showcases how great design often works silently in the background, protecting us in ways we never even consider. The reason will surprise you. We've all heard it 1,000 times: you need to get 8 hours of sleep. It's treated as this universal, non-negotiable law of health. But where did this magic number even come from? It wasn't handed down on stone tablets. The idea actually gained major traction during the Industrial Revolution, not a health guideline. Labor slogan: 8 hours for work, 8 hours for rest, 8 hours for what we will. It was a push for a balanced day, not a biological prescription. In the 20th century, sleep science began. Sleep isn't one long, uniform block. REM, rapid eye movement. NREM, non-rapid eye movement. Each complete cycle is about 90 minutes. 5 cycles times 90 minutes equals 450 minutes. 450 minutes is 7.5 hours. Round up, and you get the convenient number of 8. But here's the thing, everyone's cycle is slightly different. Some people have 85-minute cycles. Others have 100-minute cycles. For some, 5 cycles are perfect. Others feel more refreshed after just 4. And some need 6 to feel fully functional. 8 hours is really just a population average, a useful starting point, not a rigid rule. Historically, humans didn't always sleep in one single block. First, sleep. Quiet wakefulness in the middle of the night. Second, sleep. Segmented sleep was common for centuries. A consolidated 8-hour block is a modern, work-shaped invention. Obsessing over exactly 8 hours can create sleep anxiety. Sleep anxiety actually makes it harder to sleep. The key isn't to fixate on a number, listen to your own body. Are you waking up feeling refreshed? Do you have energy throughout the day? That's a much better indicator of healthy sleep than what the clock says. You won't expect this. Chapter 3. Red means stop. Green means go. It's one of the first rules we ever learn. But why those specific colors? Why not blue, purple, orange? The answer has to do with both physics and history. The story begins not with cars, but with trains. In the 19th century, the expanding railway system needed a way to signal engineers from a distance, day-night. They needed a system that was unambiguous and highly visible. For the stop signal, they needed the most eye-catching color possible. And because of a phenomenon called Rayleigh scattering, red light has the longest wavelength of any color in the visible spectrum. This means it scatters the least as it travels through particles in the air like fog, rain, dust. So a red light can be seen clearly from the farthest distance, making it the absolute best and safest choice for a danger signal. For the go signal, the choice was originally white. However, this caused problems. A stray street lamp or even a bright star could be mistaken for a go signal, leading to accidents. They needed another distinct, highly visible color. Green was chosen because it contrasts sharply with red, making it easy to distinguish. It also has a relatively short wavelength, making it stand out against the ambient light of the daytime sky. So what about yellow? The yellow, or amber light, was the last to be added to the system. It was introduced in the early 20th century as a transition signal. Its wavelength is right in between red and green, making it a logical intermediate color. Its purpose is purely to provide a warning, giving drivers time to prepare to stop safely before the red light appears. This three-color system was so effective on the railways that it was naturally adopted for automobile traffic lights. So, the colors of a traffic light aren't arbitrary at all. They are a carefully chosen system based on the physics of light, human perception, and over a century of learned association. Red's long wavelength makes it the ultimate signal for danger. Pay attention. Green provides a clear contrast for safe to proceed, and yellow serves as the essential buffer between the two. It's a simple universal language of safety, spoken in light. Chapter 4. Ever wonder why our day is split into two 12-hour chunks, instead of a more logical 24-hour system? We use a base 10 system for almost everything else. Money, measurement, you name it. The reason we don't for time goes way, way back to the ancient Egyptians, Babylonians. These early civilizations used a duodecimal, or base 12, counting system. Why? Take a look at your hand. Using your thumb, you can count to 12 by touching each of the 3 segments on your other 4 fingers. It's a surprisingly convenient, built-in abacus. The Egyptians were also master astronomers. They divided the daytime into 10 hours based on the shadows cast by their sundials. And then they added 1 hour for the twilight at dawn, and another for the twilight at dusk, making a total of 12 hours of daylight. This system allowed them to track the passage of time throughout the day using the sun's position in the sky. For the nighttime, they used the stars. They identified 12 specific stars or constellations, known as decans, that would rise on the horizon in succession throughout the night. The passage from one decan rising to the next marked 1 hour of darkness. So they had 12 hours of day based on the sun, and 12 hours of night based on the stars, giving us the 24-hour day we still use. The concepts of AM, ante meridiem, or before midday, and PM, post meridiem, or after midday, are direct descendants of this split. The 12-hour clock, with its reset at noon and midnight, is a legacy of observing 2 distinct celestial cycles: the sun's journey and the stars' progression. It's a system rooted in the natural world and the anatomy of the human hand. While the 24-hour clock, or military time, is arguably more logical and less ambiguous, the 12-hour system is deeply ingrained in our culture and language. It's a tradition that has survived for thousands of years, a daily reminder of how ancient civilizations made sense of the world around them, using the tools they had: their fingers, the sun, and the stars. Chapter 5. Take a look at the shirt you're wearing, or just imagine one. If it's a men's shirt, the buttons are on the right side, and the buttonholes are on the left. If it's a women's shirt, it's the exact opposite. Buttons on the left, buttonholes on the right. This isn't a manufacturing error. It's a deliberate design choice, with a fascinating history that goes back centuries. The convention for men's buttons on the right is believed to have a military origin. For a right-handed man, Having the buttons on the right side made it easier to unbutton his coat or vest with his left hand, leaving his dominant right hand free to draw a sword or a pistol from his waistband. It was a small practical advantage in an era where a split second could make a difference. The story for women's buttons, however, is completely different and speaks to social class. In the Victorian era and earlier, wealthy aristocratic women did not dress themselves. They had ladies' maids and servants who would dress them. For a right-handed servant standing in front of the lady, it was much faster and easier to handle the buttons if they were on the servant's right side, which meant they were on the lady's left. So, the button placement became a subtle status symbol. If your buttons were on the left, it implied you were of a class wealthy enough to have someone else dress you. Of course, the vast majority of women throughout history dressed themselves, but fashion trends have always trickled down from the elite. As mass production of clothing began, manufacturers simply copied the established aristocratic convention. And that's why this difference persists today. It has absolutely no practical function anymore. We all dress ourselves, but it's a fossil record in our clothing, a legacy of a time of swordsmen and servants. It's a tiny, everyday detail that tells a surprising story about gender roles, social hierarchy, and the strange inertia of fashion. Outro. So there you have it. From life-saving pen caps to the myth of 8-hour sleep, the world around us is filled with these hidden stories and clever designs. These aren't just random quirks. They are the fingerprints of history, science, and human ingenuity left on the most ordinary objects we use. The next time you see a traffic light change or button up your shirt, you'll know the secret history behind it. It just goes to show that if you look closely enough, even the most mundane parts of our day have a fascinating explanation waiting to be discovered. Curiosity is the key that unlocks this hidden world. By simply asking why, we can connect the dots between our modern lives and the ancient astronomers, Victorian aristocrats, clever engineers who shaped them in ways we never expected. Our world is a giant puzzle, and we've only just looked at a few of the pieces, but there are thousands more out there. If you enjoyed these tiny mysteries, like and subscribe for more surprising explanations. Which everyday question should we tackle next? Let me know in the comments below. Thanks for watching.